So today I cannot touch a lot of topics, but what I'm going to do is to tell you some stories that GIA is interested in, some items we are working on, and some interesting conclusions we in GIA research contributed to it. Diamond is a very simple material. It is composed of a carbon. Each carbon is surrounded by another 4 carbon atoms. I use a 2D diagram to show a 3D structure. The bond between carbons are so strong, and the chemistry and the structure determine all of the remarkable physical and chemical properties of a diamond. We all know this, that it's extremely hard, very stable, transparent. This list is very long. That makes diamond the best material as gemstone. What I show here is an ideal situation of a diamond structure. Every carbon atom stay where they're supposed to be. There's nothing impurity, dislocations in this diagram. Is ideal as a perfect diamond. Perfect diamond is absolutely transparent, no color. But as we all know, nothing is perfect in this world, just like a human being. And there are defects in diamond. One item could be replaced by nitrogen. If so, the diamond will show yellow color. If the nitrogen concentration is high enough, the carbon atom could be just disappeared for whatever reason from a vacancy. A diamond of the vacancy, the color will be blue. Now, if we put a vacancy and the nitrogen atom together, we call it NV center. The diamond will be pink. A lot of people are studying NV centers because they are expecting the next generation of computer will be built up using NV centers instead of the silicon. We know diamond, every single natural diamond has a defect. And there's no 2 diamonds would have identical defect configurations. So each diamond is unique. That is the basis we can, based on the defect, to analyze the defect, to verify diamond, to track diamond. That's how our GIA's diamond origin service has been built upon. As you can see, all this diamond actually from agate line, beautiful colors. Believe it or not, when the diamond crystallizes initially in the Earth's mantle, 98% of them are black color. The impurities are high enough, still in the parts per million level, but high enough to block all light come out from diamond. The nature is just so generous. After millions of years, if the defects in this diamond, they evolve, they combine together, and eventually they get transparent, and they also create all these fancy colors. In GIA, we study defects because once we know what defect gives the color of the diamond, we will be able to change it. The industry will be able to change it to create the color we like, to remove the color we don't like. That's treatment of diamond. And also based on the defects, we will be then separate which one is treated and which one is nature. And the same thing, we can use the same principles, and very important for us right now is to separate natural diamond from synthetic diamond. So in GIA, we care about the diamond, or care about the defects. Sometimes the defects are just so remarkable, and I want to show you this diamond. It is a vivid yellow-green. Most of the diamond, the color is from absorption. And whatever can leave the diamond, that's the color we see. But this diamond, the yellow color is from absorption, the green color actually is from fluorescence. So since the diamond shows strong fluorescence, the green color is so bright. Even we studied diamond color for decades, there's still a lot of mysteries we don't know. Here, I think many of you probably heard of the chameleon diamond. The yellow-green color is a stable color, but if the diamond is lightly heated, it turns to very bright orange color, and the color will come back in a few minutes when the diamond is cooled down. The same diamond, if we put it into the dark room, basically we left this diamond in the safe for 48 days. When we take it out, it is also orange color. It takes a few minutes in daylight to change to its stable color. This dramatic phenomena of a color, we don't know the physics of it, and nobody knows how to duplicate or treat a diamond that turn to green, turn to a chameleon diamond. It's just remarkable. We care about defects in diamond, either in nature or in synthetic diamonds, and we like this sentence.
Defects
Diamond
makes
is
us
like a human
interesting.
being. It's the defects that make them interesting. We study diamond, we study diamond inclusions. Once a diamond in a mineral, diamond crystallizes in the earth with the rocks surrounding it, during the growth, it will capture some surrounding rocks as its inclusion. Once inclusion gets into a diamond, it is absolutely isolated from surrounding. Diamond is such a stable material, it will never react chemically with the inclusion. And diamond also absolutely shielded from any reaction, chemical reactions from outside. So diamond is a special capsule. It preserves, the inclusion is a preserved material from the very primitive part of the earth. And from studying these mineral inclusions, that can tell us the history, how the diamond was formed, and the environment of the earth. And that's scientifically very important. I'm going to talk about the age of diamond. Everybody, we all know the slogan diamond forever. Here what I show is a black inclusion is a sulfide,
It's okay,
the
don't
red
worry,
is a
don't worry.
hydroxide, and the
I
green
get
is
it.
a dioxide. In sulfide, it could have very, very little parts per billion level of a radium, this element. Radium 187 is radioactive. We don't need to worry about the safety, about health. The concentration is so low. And in these silicate mineral inclusions, like power dioxide, they have a rare earth element, like a samarium 147. 147 is radioactive. Once these minerals get inclusion, captured by diamond as inclusion, is radioactivity, the decay continues. And it's just like a clock. And the clock goes with the half-life time is a fixed
41,
constant.
yes.
It tells how fast this radioactive element decay. With that, we'll be able to calculate the age of diamond. So here is just I try to show the history of the Earth. Earth itself is 4.6 billion years old. There are a few important
4.6.
events of the Earth I want to mention. The oldest crust now we can touch is about 4.3 billion years old. The oxygen occurred, great oxygen event of the Earth, it occurred about 2.4 billion. Dinosaurs disappeared about 65 million years ago. And the most recent eruption of kimberlite is about 22 million years ago. If you look at the age of a diamond, the Atacama diamond mine from Canada is 3.5 billion years. It's just about after a billion years form of the Earth. The diamond formed is extremely old, and the Giovanni is a very famous diamond mine in Botswana, 2.9 billion. Argyle mine in Australia, 1.6. Ellendale in Australia is 1.4 billion. The Victor mine in Africa is 720 million years. The youngest diamond so far we dated is about 650 million years old. That's Zimi from Sierra Leone. So as you can see, diamonds are really old. They formed in the Earth over a long geological history. And some of these mines we listed here already closed because of the run out of the resources. So that tells the diamond is a limited resources. By analyzing multiple inclusions in a same diamond, we know it takes millions, tens of millions of years for one single diamond to crystallize.